Depression. People frequently believe they understand the root of persistent depression. According to surveys, more than 80% of the populace attributes the problem to a chemical imbalance in the brain. That concept is frequently used in popular psychology and is referenced in academic articles and medical textbooks. A book called Listening to Prozac, which explains the importance of using drugs to fix this imbalance in treating depression, spent months on the New York Times bestseller list. Serotonin, a crucial neurotransmitter with legendary feel-good properties, is the imbalanced brain chemical in concern. The brain's systems that control everything from body temperature and sleep to sex desire and appetite are regulated by serotonin. Serotonin has moreover been hailed for years as the pharmacological MVP for treating depression. By increasing serotonin levels, commonly prescribed drugs like Prozac, fluoxetine, are intended to alleviate persistent depression. The root reasons of sadness, however, go well beyond a serotonin imbalance. The importance of serotonin in depression has often been found to be overestimated, according to clinical investigations. Despite the apparent alleviation that Prozac seems to provide for many patients, the chemical imbalance explanation may not be correct in its entirety. The most recent and maybe loudest death knell for the serotonin theory, at least in its most basic form, was a literature review that was published in Molecular Psychiatry in July. 361 publications from 6 scientific areas were assessed by an international team of scientists under the direction of Joanna Moncrieff of University College London, and 17 of them were extensively evaluated. They didn't discover any solid proof that low serotonin levels caused or even contributed to depression. The serotonin activity of those with depression did not consistently appear to be lower than that of those without the condition. Researchers' attempts to artificially suppress participants' serotonin levels in experiments did not always result in depressive symptoms. Even when the researchers attempted to account for stress as a potential cofactor, genetic tests appeared to rule out any association between genes regulating serotonin levels and depression. It is pretty damning, according to Taylor Brown, a clinical neuroscientist and postdoctoral research fellow at the Black Dog Institute in Australia who was not involved in the new study. If you were still of the opinion that it was simply a chemical imbalance of serotonin, then yeah, it's pretty damning, she added. William Churchill referred to his own gloomy emotions as the Black Hound. Some historians assumed that he suffered from melancholy. Scientists are unsure of what causes sadness after realizing that serotonin deficiencies alone probably don't. There may not be a straightforward solution, according to the research. In fact, it is causing neuropsychiatric scientists to reevaluate what depression may be. With the TB medicine, serotonin in depression became a hot topic. Ipronizid, a drug created to combat Mycobacterium TB germs that live in the lungs, was first prescribed by doctors in the 1950s. The medication wasn't very effective in treating TB infections, but it did give some patients a welcome and unexpected side benefit. According to clinical psychiatrist and head of the Yale University Depression Research Program Gerard Sanacora, their mood tended to improve, but their lung function and everything else wasn't getting substantially better. This unexpected result prompted researchers to investigate the mechanisms of action of ipronizid and similar medicines in the brains of rats and rabbits. They found that the medications prevented the animals' bodies from absorbing substances known as amines, which include serotonin, a neurotransmitter that transmits signals between brain nerve cells. Several prominent psychologists, among them the late clinicians Alec Coppin and Joseph Schildkraut, seized on the idea that depression could be caused by a chronic deficiency of serotonin in the brain. The serotonin hypothesis of depression went on to inform decades of drug development and neuroscientific research. During the late 1980s, it led to the introduction of selective serotonin reuptake inhibitor, SSRI, drugs, like Prozac. The drugs raise levels of serotonin activity by slowing down the neurotransmitter's absorption by neurons. Today, the serotonin hypothesis is still the explanation most often given to patients with depression when they're prescribed SSRIs. But by the middle of the 1990s, skepticism about the serotonin hypothesis was spreading. Some researchers found that the effectiveness of SSRIs did not always live up to expectations and did not considerably outperform older medications like lithium. According to Moncrief, the research didn't really add up. Text placeholder. Few specialists held the view that depression is entirely caused by serotonin deficiency by the early 2000s, but no one ever attempted to do a thorough analysis of the available data. Moncrief finally felt compelled to do such a research, so that we could gain a sense as to whether this notion was substantiated or not, as she put it. The serotonin theory still has supporters even though she and her team discovered that it wasn't. An article published online in Biological Psychiatry in October of last year, just a few months after their review, asserted to provide concrete support for the serotonin theory. However, because just 17 participants were included in the study, some researchers continued to be dubious. Moncrief discounted the findings as being unimportant statistically. Although serotonin levels don't appear to be the main cause of depression, SSRIs fare marginally better in clinical studies than placebos. But the exact mechanism underlying that improvement is still unknown. John Crystal, a neuropharmacologist and Yale University's chair of the psychiatry department, noted that just because aspirin treats a headache, it doesn't entail that aspirin deficiencies in the body are causing headaches. Alternative hypotheses on the causes of depression have arisen as a result of speculation about the genesis of that benefit. Some SSRIs alter the relative amounts of substances other than serotonin, despite the word selective being in their name. Some clinical psychiatrists think that one of the other substances could really be what causes or treats depression. For instance, SSRIs raise blood levels of the amino acid tryptophan, a precursor to serotonin that aids in controlling sleep cycles. This molecule has become a strong contender in its own right for preventing depression during the past 15 years or more. According to tryptophan depletion research, there is pretty solid evidence, according to clinical psychiatrist Michael Browning of the University of Oxford. A number of research on the depletion of tryptophan discovered that when given artificially low tryptophan diets, almost 2/3 of patients who had recently recovered from a depressive episode may return. Additionally, tryptophan depletion seems to be more likely in people with a family history of depression. Additionally, tryptophan increases serotonin levels in the brain as a side effect. When given intentionally low tryptophan diets, investigations on tryptophan depletion have shown that around 2/3 of persons who have recently recovered from a depressive episode may return. Tryptophan deficiency also seems to affect those who have a family history of depression. Additionally, tryptophan increases the brain's serotonin levels, which is a side effect. According to Browning, other neurotransmitters such as glutamate, which is crucial for memory formation, and GABA, which prevents cells from communicating with one another, may also be implicated in depression. It's conceivable that SSRIs alter the concentrations of these substances in the brain in order to function. Moncrief believes that rather than being a really innovative area of study, the quest for additional chemical imbalances that underlie depression is more similar to rebranding. She suggested that they could still believe in the serotonin theory, which holds that antidepressants operate by correcting some sort of chemical imbalance in the brain. Instead, she believes that since serotonin affects so many areas of the brain, it might be difficult to distinguish between its direct antidepressant impact and other emotional or physical changes that momentarily override feelings of worry and despair. Neurotransmitter deficits are not the only possible explanations for depression. Some people hunt for genetically based offenders. It was generally heralded as the start of a new era in medicine when the first substantially full draft sequencing of the human genome was published in 2003. Since then, roughly 200 genes have been linked to a risk of developing depression, and researchers have discovered genes that explain a wide range of illnesses. Several hundred other genes have been found to potentially increase risk. People need to realize that depression has a hereditary component, according to Crystal. Only psychological and environmental aspects were taken into account until fairly recently. But our understanding of genetics is still limited. Crystal brought up twin studies, which indicate that 40% of the risk of depression may be hereditary. However, just approximately 5% of the genes that have so far been discovered appear to explain. Furthermore, merely carrying the genes for depression does not ensure that a person would experience depression. Additionally, the genes must be somehow triggered, either internally or externally. The difference between environmental and genetic influences is occasionally made in error, according to neuroscientist Sri Johnson of the University of Michigan. The interaction of genetic and environmental variables is crucial for the majority of common features of interest. By mapping patients' genomes and closely studying how people with various genetic profiles react to environmental changes, SIN's group investigates the genetic basis of sadness. The stress generated by the COVID-19 epidemic has recently been examined. Individuals' susceptibility to developing depression in response to certain forms of stress, such as lack of sleep, physical or emotional abuse, and social isolation, might vary depending on their genetic makeup. SIN's group maps patients' genomes and closely monitors how people with various genetic profiles react to environmental changes in order to understand the genetic basis of sadness. They have recently examined the stress produced by the COVID-19 epidemic. Different genetic variants can influence whether people experience depression in response to specific forms of stress, such as lack of sleep, physical or emotional abuse, and isolating themselves from others. The optimum type of treatment for a patient may one day be determined by research on these genes. Some genes may make a person more likely to benefit from cognitive behavioral therapy than others. And some individuals may respond better to SSRIs or therapeutic ketamine. SIN noted that it is still much too early to determine which genes are responsive to certain therapies. In a recent conference presentation, a group led by Jonathan Reppel, a psychiatry researcher at Goethe University in Frankfurt, Germany, described how they scanned volunteers with acute depression and discovered that their brain structures were different from those of a control group who weren't depressed. For instance, the white matter of the nerve fibers in the brains of persons who were depressed had less connections. However, Reppel points out that there is no brain scan threshold for poor mental health, making it impossible to identify depression. Reppel's team performed further brain scans 6 weeks after the depressed group had finished their therapy. This time, they discovered that when the depressed patient's symptoms subsided, the general amount of neuronal connection in their brains had grown. It didn't appear to matter what sort of care the patients received to achieve the rise, as long as their mood lifted. Neuroplasticity is a phenomena that may provide an explanation for this alteration. According to Reppel, neuroplasticity refers to the brain's capacity to build new connections and modify existing wiring. A person's mood may be improved by using neuroplastic effects to boost interconnectivity if depression is caused by too few or lost connections in the brain. Reppel cautions that there may be still another reason for the outcomes his team saw. Perhaps inflammation affected the brain connections of the sad patients. Chronic inflammation impairs the body's capacity to repair and can eventually weaken synaptic connections in brain tissue. It is believed that the loss of these connections is a factor in mood disorders. This idea is well supported by evidence. According to Charles Nemiroff, a neuropsychiatrist at the University of Texas at Austin, psychiatrists have shown that communities of people with chronic inflammatory disorders like lupus and rheumatoid arthritis all have higher than average rates of depression. The researchers believe that the inflammation itself may possibly be a component in the patient's depression, in addition to the patient's knowledge that they have an irreversible, degenerative illness. Medical experts have discovered that in certain people, causing inflammation might result in depression. Interferon alpha, which is occasionally used to treat chronic hepatitis C and other illnesses, overwhelms the immune system with proteins known as cytokines, chemicals that help reactions ranging from moderate swelling to septic shock. This generates a large inflammatory response throughout the body. Loss of appetite, exhaustion, and a reduction in mental and physical activity are all signs of significant depression brought on by the abrupt surge of inflammatory cytokines. Patients using interferon frequently describe feeling abruptly and occasionally severely depressed. Researchers still need to identify the cause of the inflammation, even if it is chronic inflammation that has gone unnoticed and is the cause of depression in many people. Chronic inflammatory reactions can be brought on by autoimmune diseases, bacterial infections, high levels of stress, and certain viruses, like the virus that causes COVID-19. Brain tissues may experience direct viral inflammation. Knowing which of these reasons is at play may help in developing a depression anti-inflammatory medication. It's also not clear if reducing inflammation alone would be sufficient to lessen depression. Clinicians are still attempting to determine if inflammation causes depression or the other way around. It's kind of a chicken and egg thing, according to Nemiroff. Similar to how doctors today think of cancer as referring to a plethora of different but connected malignancies, some scientists are increasingly trying to redefine depression as an umbrella term encompassing a suite of related disorders. Treatments for depression may need to be individualized, just as each cancer must be avoided or treated in ways according to its etiology.